Okay, good afternoon, everyone. Welcome to this session. This is Shan from Alibaba Cloud in China. And today I'm going to share when we use Hyperledger Fabric, the problems in storage and network, and how we solve them on cloud. Okay, first of all, I want to introduce a bit the background. So I assume everyone here knows about what blockchain is, just as described in this narrow sense. But what is more attracting us is that in this broad sense, we think blockchain is a kind of new schema and collaboration model for the organizations, individuals, and machines to construct a distributed trust network to connect their trusted data and let the value start to flow in among them. So this will be a promising future, not only for most industries, but also for the whole society. So therefore, Alibaba Cloud started the journey in blockchain, and we chose Hyperledger as one of our major directions. Here are the key reasons. The first one is the openness. Openness brings people the trust in technology rather than a proprietary knowledge which runs like a black box. People cannot trust it. The second one is the inference. With this large inference, we are able to build this global, large technical and business ecosystem. And the third one is that we found in Hyperledger, especially in Hyperledger Fabric, it was born with our enterprise-oriented design. That means from functional to architectural, it provides very high standard of security, stability, availability, scalability, etc. So these are our enterprise customer care most. So Alibaba Cloud is dedicated to build trusted infrastructure for everyone and position itself as an open platform and is willing to contribute to the ecosystem. And the Alibaba Cloud's mission is to help enterprise to do the digital transformation. So in this sense, we highly value this. And on the other hand, we think these also are the key factors for blockchain technology or blockchain community will succeed in the long term. So what have we done in the past 2 years with Hyperledger? So early in 2017, in October, we released the first blockchain solution of Alibaba Cloud Container Service. In that solution, we provide one-click deployment for distributed fabric network to reduce the hours or days effort into just several minutes. And in December last year, we upgraded to support the Kubernetes and also incorporated Explorer. And in July this year, we launched the blockchain as a service in China. And we are also globally the first blockchain product which combines Intel SGX technology with Hyperledger Fabric. Then in September this year, together with Brian Bendoff in Hangzhou, we made Alibaba Cloud Blockchain as a Service globally available for the whole international market. So today, just announced in this morning, we are very honored to officially become the member of Hyperledger. And by close collaboration with Hyperledger, we expect more achievement in the 2019 and ahead. Okay, today you have seen blockchain has been applied in many industries and scenarios. And in Alibaba Group, we have also applied blockchain in many industry and scenarios as listed in this slide. And just give you a few examples. We have helped our customers to use blockchain to encourage safe driving and avoid the traffic accidents. And customers managed to create value out of the driving data contributed by people. And the second example is that we are working with the AI team to build a trusted digital content platform for the copyright protection and the trading of digital contents. The third example is that we are working with IoT team to build a platform for trusted device access and trusted data for the industrial internet. So in our vision, we are not only creating the incremental value for enterprise, which is improving the efficiency and reducing the cost, we are also keen on creating the transformation value for enterprise. That is the new business model, the new scenarios, and new economic, which will not exist if without blockchain. Okay, so when we apply blockchain in enterprise scenarios, we have encountered a series of challenges and problems, and we managed to solve them. For example, in security, we use SGX to protect our Fabric private keys, and we also have a lot of security design to address the security risk. And performance, after optimization for a single channel with 4 peer nodes, using Caliper as a benchmark tool, we managed to achieve 1,600 TPS for writing and 7,000 TPS for query. But today, I'm going to share our practice around the storage and network. So first is storage. Why storage is important? Because the core of the blockchain is the ledger, and the ledger data resides in the storage. So this is the reason. So we encounter these 2 major problems in the storage when in our customer engagement. The first one is how to do storage capacity sizing or planning. Actually, we had not found any guidance or knowledge about this question before, but for our customer, they need to do the storage capacity planning at the very stage, especially in the private cloud deployment or local center deployment. So this is one key problem. The second one is how to address the storage challenge. I'll explain it later. So here is how we solve the first problem. We deploy Hyperledger Fabric in container and on Kubernetes cluster. So we summarize the data paths of the Fabric nodes inside the container and also the contents in this data paths. So now we managed to know where the data is and what the data is. And the second thing is that we have done a trend analysis for the data growth in the Hyperledger Fabric network. So as you can see in the slide, in this red spot indicate the place where the storage consumption rate grows very high. And the yellow spot indicate the medium rate of storage consumption growth. So this is because in the red spot, it is the peer and order which maintain a series of append-only blockchain file, and this will grow directly as the transaction grows. And in the yellow spot, it is the Kafka broker, which also store the transaction data in the topic queue, but we can set the retention period to mitigate the pressure. And the other part is like the StateDB. It also stores the value which is related with the transaction, but it will not always grow, so we'll explain later. Okay. So with this trend analysis result, and then we have done a series of source code analysis and server testing, and today we come up with this version 2 of the formula, which is for estimating the Hyperledger Fabric storage consumption size. Okay, and you can also use the Excel format to customize the input parameters according to your scenarios and your deployment. So next, I will explain how we come up with this formula and the magic number and variable inside the formula. As highlighted in the yellow color, the 2.9 kilobytes is the net size of a transaction in Fabric. So this is based on the source code analysis and the test results. And the 1.9 kilobytes is the net size of a block. And the 3.34 kilobytes is the rough size for the transaction plus the footprint in the block index DB and history index DB. So this is based on the statistic of our test results. And the transaction payload multiplied by 2 means that each transaction actually contains the chain code proposal payload and the proposal response payload. So both of which contain the transaction payload. Oh, next one is the number of blocks. This actually is a number which is hard to determine because a block will be cut when any of the below condition will be is satisfied. For example, the first one is that how long the block has been waiting for a transaction. The second one is how many transactions in the block has been assembled. The third one is how many bytes in size for transaction in the block. So this is very hard to determine, but for a specific scenario, we can still calculate. For example, in a high throughput scenario in which the transaction keep coming in at a very high speed, we assume the max message count is 10. That means for 10,000 transactions will have 1,000 blocks generated. So this is one example of calculation. And next is the number of Kafka topic replicas. So this is not the number of Kafka brokers, but actually it's the number of Kafka topic replicas. And by default, Fabric use 3 as the default value. And the second one is the CouchDB compression rate. So actually, the transaction payload stored as a value in the stateDB. And as you can see in this configuration, the CouchDB by default support a snappy compression algorithm by default. But the actual compression rate varies, depends on the payload contents. If no compression at all, we take 1 for this value, for this variable. But if in the extreme case, we use a single letter, we repeat 1,000 times. And in this case, the compression rate may nearly to 0. So this is how we take the value for this variable. And the next one is scenario type. Because for create scenarios, new key value will be created in the stateDB. But for update scenarios, no new key value will be created in the stateDB. So it is 1 and 0 for different cases. OK, so how this formula works, what's the effect? To be honest, in the very beginning, our intention is to get a rough estimate about the level of storage consumption. For example, whether it is several gigabytes or hundreds of gigabytes of ledger data. But after this, using this version 2 formula and compare with the actual storage size, we found that you can see from this diagram, the orange line and the yellow and the blue line already overlap together or very close together. So today, the result is much more accurate than we expected. So with this deeper knowledge about the storage size, now we can see the challenge in the storage. The first is the storage consumption keeps growing fast. As you can see in the formula, it is many times of the size of the transaction number and the transaction payload. I remember there was a feature and a design document in the Fabric community in the JIRA talking about some cleanup of the ledger data, especially get rid of the invalid transaction. But actually, even in our testing now, even all the transactions are valid transactions. The rate of storage growth are still quite horrible, especially when some of the customers want to apply blockchain in a business which is throughout the China, the whole national scale, and want to run it in production for years. So this will be a very challenging problem. And the second challenge is how to ensure the stability, reliability of the storage and minimize impact to business applications. So thanks to cloud, we managed to find a good solution for the above challenges. So we chose the Alibaba Cloud NAS and Alibaba Cloud Disk as our ledger storage, and we also choose these two because they provide very high reliability as stated here. And also we choose the SSD type for I/O performance. And Kubernetes provide very good abstraction for storage resources. So we use persistent volume and persistent volume claim to request and mount this storage into the Fabric pods without caring about the details of the storage. And in this diagram, you can see how we apply this storage with different Fabric nodes. And I want to explain a little bit about, we found Alibaba Cloud NAS is quite fit for the blockchain ledger in 2 reasons. The first one, it supports a seamless and dynamic storage expansion when your size gets reach the bar. And during this process, you don't have to restart or interrupt your Fabric nodes or your applications. The second thing is that some customer concern that as time goes, when the file system get the larger size, will that this I/O become very slow? So to the contrary, NAS has the characteristic that the larger volume is, the higher throughput is. That is provided by Alibaba Cloud NAS. So in this sense, we can eliminate this concern of the customers. So today, in our actual customer reference case, there is some blockchain system have been running in the production environment for months and reaching like millions of transactions and hundreds of gigabytes of ledger data on our platform. Okay, the second big topic is network. This actually is a very large topic, and today I only managed to talk about some typical connection patterns based on our practice. Okay, maybe some of you have already been aware or know well about how the connection are working inside Fabric, but to most people, it's still quite complex and hard, not so clear. So we managed to summarize the connection model inside the Fabric. So actually, there are two types of connection. The first one is transaction flow related, which happen in sequence. As you can see in these 4 color of lines, so the client in the beginning, connect to the CA for registration and enrollment, and then connects to the endorsing peer for the transaction endorsement, and then connect to the order to broadcast the transaction to the order, and then after order the transaction assemble into blocks, it will deliver the blocks to all the peer within the channel for validation and commit. So this is the first type of connection. And the second types of connection happens all the times. It includes like each organization's leader peer, it will connect to the order to pull the data from the order and then initiate a dissemination of the block data to a random number of peer inside the organization. And second one is each organization's anchor peer will be connected for discovering the peers in different organizations. And among all those peers, they will have a gossip communication, mainly for 3 purposes, like detecting peers and disseminate the ledger data, and for the new peer, we transfer the ledger to it. So with this connection model summary, we have a conclusion that for Fabric to function normally, we need to have a full mesh network for it. Yeah. And then we come up with some typical connection pattern to connect Fabric services. The first one is quite simple. If we deploy the Fabric network inside a Kubernetes, we can just use the Kubernetes service name as a Fabric service name. And Kubernetes will resolve the service IP name to the post class IP automatically. So behind the scene, it is the kube DNS to resolve the service name to service IP, and then kube proxy to translate the service class IP to the post class IP. So what you need to do is just to define the Fabric nodes using the Kubernetes service name in your config.txt.yaml or cryptoconfig.yaml and any similar configurations. So this is very easy to use and simple. I usually use it in the development and testing or the private chain deployment. And second scenario is Fabric services in different regions. So in these scenarios, for example, we have the peer organization in one region and the other service in another region. So we still use Kubernetes as an example because today it is already a standard for application infrastructure. So here we can use an external service endpoint to define this order. So we can define the external address and the port of the target order and define this inside this region A, so that peer can connect to this external service endpoint and finally reach this order. So in this way, we can still use Kubernetes service name for the Fabric service, but it requires a little bit extra configuration effort. So usually we use this way for our proof of concept or prototype system. Okay, the next one is more flexible. Is that still in scenario of different regions, but here we can use a global host name for every Fabric services, and then register the host name in a global DNS, and also we assign public IP and the public port for each services, so that when we visit this host name, the DNS can translate to the public IP of each services. So this way can satisfy most of the basic customer requirements and very flexible and also provide a very good abstraction, especially for external blockchain applications. So today, this is a default option of Alibaba Cloud Bus. And the next one is quite a bit more complex. It's for a scenario that the different customers, they want to deploy the Fabric nodes in different VPC or private network on the cloud. And they also have Fabric nodes or services in the local data center, and they want to establish a consortium network to connect all the customers' nodes. So in this case, also thanks to cloud, we have a CN, it's called Cloud Enterprise Network. It can connect all the VPC into a ring network so that this VPC can connect to each other using just internal IP and without exposing to the public network. And also, we also want to leverage the flexibility of using the host name to visit these services. So we also use a DNS private zone product, which can ensure the resolution of service name to IP only effective within these VPCs. So also for those customers who are in the local data center, we can use either VPN or the lease line to connect to any of the VPC and furthermore connect to the whole ring network. So this is already supported by Alibaba Cloud Bus today, and I want to emphasize that it is not only applicable to Hyperledger Fabric, but also applicable to any other blockchain technology. So in the end, I want to do a quick summary. So today, we think the relationship between cloud and blockchain is a kind of perfect match. And by collaboration with Hyperledger, we wish the strengths of both sides can be reinforced. And also, we welcome any partners and friends around the world to join us so that we can accelerate the development of the blockchain system together to a greater success in future. OK, that's all for my sharing for today. And thank you for listening. And any question? Yes.
Oh, it's a brilliant presentation.
Thank you.
A quick one here. So during the Alibaba Cloud test, do you have any test result for the maximum nodes supported by Alibaba Cloud?
OK, this is a good question. So actually, we have done a first round of performance testing, and also we have done a series of more performance scenarios. So currently, we have tested like the according to some custom scenarios, like 10 organizations with 2 nodes for each, so it can run in their test environment. So currently, we have not seen some physical limitation. So, but as the scenarios of performance goes on, maybe we'll have more summary about this. Yeah. Yeah. OK. Any other question? OK. OK.
Clustering, are you using auto scaling using pod or the vertical or the horizontal node scaling as well?
OK. OK. Okay. So yeah, this is a very interesting question about auto scaling, about the deployment on cluster. So actually, we have done some analysis about the application pattern for blockchain. It contains 2 parts. The first one is the blockchain network or the system itself. It's a kind of data-centric, complex system. So for such a system, like the database, we are not treated as a stateless or can be scaled easily. So it's kind of like maybe you use some node selector to deploy combined with a local volume, or you use just now the NAS or Cloud Disk for the data persistence. But the principle is that you will not easily scale out one peer node easily. This is not the by the native design. So we more like use auto scaling for our blockchain application, because blockchain application may be stateless, maybe a web application or any other application. So that's a good example to apply the auto scaling. So that's in our practice. So for blockchain nodes, we don't easily do the auto scaling for the expression of the peer node. Yeah. But on the other hand, the peer node itself is also natively provided high availability because they have the same ledger. They can replicate each other. They can provide the services when one goes offline. Yeah. Okay. Not sure if I have answered your question.
Yeah. My question is mainly about Kubernetes. You can add more talking about Azure, because we tried using Azure. So you can use you can add more nodes. right?
Oh,
So
the nodes.
I'm talking about virtual machines.
Okay, virtual machine. Okay.
Add
Yeah.
more VMs.
Okay.
And at the same time, Kubernetes provides pod
Yeah.
scaling,
Okay.
which can also, using the same number of
Yeah.
underlying VMs,
Yeah.
you can spin up more pods
Yeah.
behind the Kubernetes proxy.
Yeah.
Right?
Yeah. So it's quite coincident that I also come from the container service department of Alibaba Cloud. So we have already supported the scenario described as the dynamically scale out to more virtual machine under the Kubernetes. And also, we can auto-scale the pods of the Kubernetes according to the autoscaler, some criteria we set. Yeah. And also, let me example. Yeah. So this is already a supported feature by Alibaba Cloud Container Service.
So based on the CPU and memory
The CPU, memory, and customized metrics.
Okay.
Yes, already supported.
Auto scaling is on.
Okay,
Thank you.
great. Thank you. Okay. Okay.
So great talk, by the way.
Thank you.
Current version of Docker of Fabric
Yep.
uses Docker and Docker to build and spin up the chain code container,
Yep.
which puts it outside of Kubernetes. So Kubernetes can't monitor it. How do you deal with that?
Okay. Oh, this is a very good question. I love very much because just several weeks ago, I presented a speech at the LinuxCon and Cloud Native Con talking about this topic. So this is a long existing challenge. And because in the life cycle of a container, the peer will invoke the Docker daemon to first create a Fabric CCNV-based called chain code builder environment to build the chain code image, and then call the Docker daemon to start the chain code image as a chain code container. This is all out of the Kubernetes lifecycle. It's hard to do the management throughout the chain code lifecycle. So we have already in Fabric Jira have a feature about taking the chain code management into the Kubernetes like POP, but still not implemented. But we think that's the ideal way to solve the problem. So we have also experienced the Docker in Docker solution, but we found there are more disadvantages than the advantage of this approach, because especially the speed will become very slow because you need to pull the 1.3 gigabytes of Fabric CCNV-based image each time you start the peer. And also, the Docker in Docker approach is more used in the CI/CD and DevOps, not for production, because the stability challenge is quite obvious. So today in Alibaba Cloud Bus, we use another way is to solve the key problem first. We ensure by using the configuration and some IP table network policy, we ensure the communication between peer and chain code is okay, and then we use the network policy to restrict the inbound and outbound connection for the chain code container. So this still, I think, a trade-off. Maybe in future, maybe we or you, we can together contribute to the final solution from the source code level to this problem. Okay. Thank you. Okay. Okay.
Thank you very much. Can you probably share your experience on how putting nodes and peers in different regions affect the actual blockchain performance? Like, does it actually influence it somehow? Or like when you have a node, one in, I don't know, one in Singapore and the second one in US and the third one in China, like how does it affect the blockchain performance?
Okay. Okay. Yeah, I can. Yeah. So this is a very good scenario. Actually, to be honest, I have not done exactly the same scenario, but we can talk about based on the performance experiences. So first principle is, I don't know whether the English term for this is like the bucket theory. The shortest part will determine how many water you can contain in the bucket, right? So it's same to the performance, because in the end-to-end architecture, the weakest part determines the whole performance of the whole system. So in our performance, we found if in a very high-speed network environment, then the major bottleneck is in the CPU, the computing power, because we found the Fabric is very calculation-intensive kind of system. So this will be one major optimization. And the other one is like the configuration about the, just mentioned, like the, how a block is being cut, the parameter in the channel config. So this is the second optimization. But in the scenario just described, in the cross-region, especially cross-continental scenarios, network will become a very serious part. I think in maybe two aspects. One is getting the endorsement, because the client needs to connect to different peer. According to the endorsement policy, to different peer, organization peer, get the endorsement response and then connect to the order. So this part, the network latency, maybe will become a problem, right? By the way, I want to mention there are two metrics for performance. One is the transaction per second TPS. The second one is the latency. So in this part, network latency may decide the whole performance latency. And second one is about the order to deliver the blocks to other peers. And the third one is if your peer relies on the channel event to notify about the final commit of the block, you also wait for the channel event to arrive at the client. So these three parts may come together with slow down the whole performance, because network latency is very significant in these scenarios.
And what are the best practices? For instance, do you need to deploy orders in all these regions in order to make it like improved, or it doesn't help?
Okay, because today Fabric, before Fabric support RAF in the future versions, today the Kafka is still not so distributed, because order in nature is just a Kafka producer and consumer client. So maybe you can put order in very long distance. So this will slow down the connection between client to the Kafka broker. So this may be one solution. But I cannot guarantee the performance will be better in this way. Yeah. So let me think about any other approach for this scenario. Network latency peer. So because different regions, the network connection or the bandwidth will still different. So we'll do a good planning about the placement of different nodes in these regions. So because we know the network speed, especially when it comes to cross China, from China to overseas, may be different. So yeah, you know it. Yeah. Okay. Okay. Okay.
All these four different nodes of physical VMs, even though they are located, in 4 different regions of the world, they are part of the same Kubernetes cluster, right? Okay.
Yeah.
We are not talking about all of them are worker nodes, physically located in different parts. Is that the scenario that you presented earlier? Global network.
In the scenario I just presented, it is a different Kubernetes cluster in different regions. But actually, today our container service also support different kind of Kubernetes. Maybe not in blockchain, but for example, with the Kubernetes cluster spanning different availability zone. That's one scenario. And the other one is use Kubernetes federation to combine different Kubernetes in different regions into single cluster. That's a federation. Okay.
And just a follow-up on that. Did you use a single CA or distributed CA?
Okay. This is also a good question. There are different choices. First, we identify CA is a kind of low-frequency usage and not the transaction directly related services. So Kubernetes provide very good recovery or kind of cold standby HA. So we use single SA can satisfy most of the situation. But higher stand-up, we can use the CA cluster, because Fabric also supports the CA cluster using a cluster of database for that deployment. Yeah. Okay. Okay.
Hi. I was wondering, is it possible to connect a peer from Alibaba to IBM platform, for example?
Oh, this is a very interesting question. Actually, I replied to Chris Ferris last week in the Hyperledger mail group, because Chris proposed interoperability between different blockchain vendors, especially Hyperledger vendor, to create like a marble application which can run between different blockchain as a service vendors to make it work and prove the interoperability is feasible. So I think this is a good direction that we are working towards it. So maybe in future we can work together to make it happen. Okay. Okay, sure. Yeah, we have more friends joined together today. Okay, really appreciate it. Okay, any other question? Maybe I should leave to the next speaker. Okay, thank you very much.